Okay, so in this video, we will learn all about recursion, which is a programming concept, I guess, or a programming strategy, I suppose. Sort of a different way of looking at how we might do a repetitive process. So away we go. So what is this, right? So we'll get right into what is recursion and what does it mean for us. So we'll view recursion, which is a general idea, through the lens of a recursive function. So of course we know what a function is. But what's a recursive function? So a recursive function, at its most basic idea, would be a function that calls itself, right? So it's a function that it's going to look like a function. Maybe it's a void function, or maybe it's a return function. And it's going to have, usual components, maybe have some parameters and actions and all of that. But the idea, or what sets this apart from any other function that I think you've ever written, is that at some point in the execution of the function, it's going to decide, or the programmer is going to decide, that it would like the function to run again. So essentially, right, what's the idea then of what a recursive function does is that since the function is going to call itself, if you think about a function, a regular function that you've written hundreds of, you start at the top of the function and you run the function. And when you get to the bottom of the function's over. And then you go back to the main, right? But a recursive function is going to have the property, or have the idea, that in executing the function, at some point, you're going to decide that you actually want to repeat the function. In other words, you want to just call it again. Now, why would you want to do that? Well, I mean, there's probably a lot of reasons, but I'd say maybe one or both of these is true. So it's possible, right, that when you're writing this function, in the course of executing it, as I said before, you may decide, you know what, I need to repeat this function. I want to start at the beginning again, and do whatever the function does. I want to do that again. However, of course, I don't want to just do it again in terms of the same function. I mean, that would of course be silly if you're just calling a function over and over and over again, and it's producing, or it's doing the same thing every single time. Well, that's probably like an infinite loop kind of a process. So what are you going to do is that when you do call the function from within the function, which is a little trippy at first to get a handle on, but you're going to at least be sending it some sort of updated information, probably in the form of some updated parameters. So while, yes, you are going to call the function from within the function, which in essence is going to have you repeat the function, you are modifying it a little bit in the sense that you're going to send it some modified information, which we'll get to what that means, right? So that may be a situation, right, where you'd use recursion, or you'd use a recursive function. It may also be the case that the function itself, in terms of what you want to do, is maybe quite simple, just maybe a task like printing, or searching, right, looking for something, and it's really the case that while you do want to do this action, the main thing you want to know, or the main thing you're trying to sort of figure out, is when is the right time to do it. So in that sense, I might think about using recursion to say, well, let me call the function, and if now is not the right time to do it, whatever this function's supposed to do, maybe if I call the function again with some updates, maybe that'll be the right time to do it. And then if that's not the right time, maybe I'll call let the function call itself again with some updates and say, oh, maybe now's the right time to do it. Something like that. If you think about that, right, we've done some types of programs where we've done things like that, where mostly we're just looking for when is the right time to do this. So maybe that's another good example of when we might use recursion. But in both cases, a recursive function will, at the end of the day, act like a loop. In particular, probably it's helpful to think about it as a do-while loop rather than a for loop, in the sense that it is, when a function calls itself, essentially, of course, that means repeat, which we know what that means, right? Loops do that all the time. Loops say, oh, okay, I run the loop once, and then when I get to the bottom of the loop, if my condition is still true, I repeat the loop. So in many ways, right, we're going to look at coding things, at least for now, that you already know how to code with a loop. But we're going to get a little bit of practice with this idea of recursion. We're going to recast those things, those loops, as recursive functions. And for now at least, this is going to mostly just be a fun activity, I suppose. But when we get to some of our more advanced data structures that we're moving towards, we're actually going to need recursion. And by that I mean that there isn't really a very good way to code some of the things that we're going to eventually want to be able to do with just loops. And we're going to actually need to be able to do this process. Right? But let's get started with just an easy thing so we can get our feet wet. So on the left here, you see, of course, an easy program that is just our very basic printing function or printing loop for a linked list, right? So of course I start at the beginning of the list. I keep going while I'm not at the end of the list, and I print the number, and I go to the next one. And then if I wanted to, we don't usually do this, but if I wanted to be a good person, once I get finished with the loop, I could print a little all done message or something like that, right? Okay, so of course, yes, if you need to print a linked list, then of course, sure, this code on the left is just fine. But in terms of thinking about recursion and a recursive function, and we don't know all the details yet, so this is us just taking a first crack at it. If I wanted a printing function, which of course is what I'm setting us up for here, void print, we know that means that this is a function that's going to print, and it has a parameter, which is a pointer, presumably to where we are in the list. How could I do this? Now, of course, the smart aleck answer is take that code and put it in the function. Aha. Okay. Well, I suppose that's true that you could do something like that. But then, of course, this is simply a function that then does the loop, which that's not really that's not what recursion is supposed to be all about. Recursion is supposed to say, well, there's some crafty way for me to involve calling the function multiple times or calling the function from within the function in order to simulate a loop. So while I am going to do a bit of a translation from left to right here, I'm not going to do it that way. I'm going to instead try to think, all right, so if I'm printing the numbers in this linked list. I guess I would think to myself, well, there's really only two different things that we do when we are scrolling through this list. And if we look back at our code that we already have, what are the two options of what we might do? Well, if I'm not at the end, I do that. And if I am at the end, I do this. Right? In some sense, I could say that, of course. In some sense, I could say, well, that's kind of how this loop reads, right? If I'm at the end, do behave one way. And on the other hand, if I'm not at the end, behave a different way. Right. So I could certainly do that. That sounds almost like an if and an else, doesn't it? Right? Because, of course, that's the idea of an if and an else. So if I'm thinking about a structure for this recursive function, how about I just on some intuition here say something like, well, if I'm trying to print, I kind of feel like I have two cases of what I might do. If I'm at the end, I'm going to print this message. If I'm not at the end, I'm going to do those two things. Sorry, I don't know if I swapped A and B or not there, but right? That's kind of what I want to say here. So if I'm printing, if I'm trying to write, so what is this print function supposed to do? I don't know. Naively, I might say, well, if you're at the end, what do I want to print? I want to print a message that says, all finished, or something like that. Otherwise, if I'm not at the end, then what do I want to do? Well, then I want to print the number I'm on. I want to toggle temp. And I want to toggle temp, I guess. End of sentence. Okay, so far at least, I'm trying to help you out here a little bit with organization. I mostly, in fact, not just mostly, I think I literally just moved the code from our traditional function, which is handled with a loop. I moved that into what are essentially just cases of a function. But hopefully you can kind of, right, I don't think I'm saying anything too crazy here. This does kind of make sense when you read this from top to bottom. So this is a function whose task it is to print stuff. So I believe I have two cases of what I might want to print. On the one hand, case A, if you're at the end, print a little finished message. Or, if you're not at the end, print the number that you're on and go to the next number, or go to the next node, right? So I'm just going to clean this up a little bit. Maybe I'll leave my A and B. Well, leave them over there. Right, so now if I read this from top to bottom, though, well, first of all, I might have a question about what does this look like in the main? Right, because so of course this is a function. So this has to be called from the main. This loop that's over here on the left, I mean, we've written that loop, and if it's just part of our program, then it itself lives in the main. It doesn't have to be called. But since this is a function, of course, this would have to be called. So in the main, I'd have to say something like, oh, print, right? That's the name of the function. And of course, I have to send it a parameter because it's right, there's a parameter here, which is a temp pointer. Well, if you think about it, what should I send this? Well, if my goal is to print this list, I probably want to start at the beginning. And how might I say that with a function is I might say, well, let me send this function first, the first pointer. Because that's going to say then when the function gets called, this is going to be pointing to first when it's called. So temp is going to be equal to first, right? We know that when we call a function, whatever we send it as a value is what gets inherited or what gets stored in whatever parameter the function has. So first will be stored in temp. In other words, temp will be pointing to first. So that at least sort of actually now, if I'm going to do my little matchy thing here, that's C from the left. I'll put my A and B back in one more time, right? This is my A, and this is my B. So I've mostly, again, just moved things around. But now before I'm ready to call us champions of recursion here, this is where I would stop in class and say, now somebody tell me what's wrong with this and why this isn't going to do, why what we just wrote on the right isn't going to do what we expect the left to do. So I'll let you think for 5 seconds or so. So if you think about it, on the right here, I have no action that says go back and repeat, right? So literally, I mean, hopefully you can understand, right, that if I type this in on the right here, if I type this into a program and ran it, okay, so I call this function, I send it the first pointer, so first is stored in temp, and so so when this runs, right, so I come here, I start the function. Well, if first is null, it's going to say all finished. And otherwise, so first isn't null, it's going to print what's in first, and it'll toggle temp to go to the second node. Long dramatic pause, because then I get to here, and my function's over. Ooh, okay, so, yeah. So what I've written over here is not actually a function that's going to loop through and print the whole list. This is a function that would print the first node. But what I'm missing so far is I guess I'll call it fourth component, which is the while action over here on the left. I need to be able to do some sort of, oh, and repeat me. So that's going to be covered. Let me just clean this up a little bit. So so if I read this from top to bottom, I have no go back and keep going kind of thing. So instead, I'm going to say, oh, all right, well, what is it that I want to do? Well, I don't want to keep going when I'm in this case, right? When I get to the end, I really legit want to print all finished and then stop, right? I have nothing more to do after that. So I'm pretty happy with case A over here, that this pretty much does what I want it to do. If I'm at the end, print your little message and then do nothing more. But it's in this case where I might say, if I'm not at the end, then I want to print the number, great. I want to go to the next box, great. But here's where, of course, I want to say something like, and repeat. Well, the cool kids' way now of doing that is to simply call the function again, and I'm going to send it my updated, remember temp got updated right above that. And I'm going to send it temp so that, right, the first time through, when I call this function, of course, I'm sending it first. So I'm going to have first stored in temp. In other words, temp is pointing to the first one. So I'll print the first number. Right? So I'll print the first number. I'll advance temp to the second box. And now I'm going to call the print function again. Now when I call the print function the second time, temp is going to be pointing to the second box. So when I come back through a second time, unless I'm at the end, I mean, if I'm at the end, then it'll say stop. But if I'm still not at the end, I'm on the second box and there's something in there, print the second box, advance to the third box, and print again. And now temp will be pointing to the third thing. And let's just suppose for a minute that the third thing is null. In other words, that there's only two boxes. Then the third time through, this case will be true. I'll print a nice all finished message. And since this case doesn't call the function again, I'll actually get down here to the end of the function, and it'll stop. All right? So I'm going to clean up all my little things here. I'm going to leave the A, B, C, D stuff. Oh, I'm sorry, I didn't put D in. So this last line, right? That's my version of D on the left. Right? So what we see on the right, I'll stop writing now, right? But what we see on the right is exactly the recursive translation, I guess, of this simple printing loop on the left. And for the most part, I hope that this doesn't seem difficult, because for the most part, you're just taking, I mean, I wouldn't necessarily encourage you to write it out regular and then convert it, right? We'll hopefully get better at just sort of going right to this on the right. But I want to convince you, hopefully, or show you, and hopefully convince you, that all of the pieces that are usually in these loops exist in the recursive function. They're just moved around a little bit, right? And structurally, we're kind of just organizing it a little bit differently. All right? So hold on to that as a good reference. Oh, I think I wrote it nice over here. I did. Okay, so this is just the same thing, I think. So here's a cleaned up version of the program that we just wrote. Okay, so, and again, hopefully this is our first one. I'll tell you a small personal story, which is that everybody learns recursion at some point in one of these courses, early programming type courses, and it's always a little tough at first. And we literally have just done one example, so it's not, so hopefully it makes sense. But if it doesn't, this is the kind of thing that after you do a bunch of them, you eventually sort of get the hang of it. But it's a different way of thinking, right? In the same way that that there was a different way of thinking when we switched to linked lists as compared to arrays. There's a different way of thinking about doing things recursively rather than traditionally. Or again, think about last semester when we didn't know functions at all, and we just dumped everything in the main and didn't even know what a function was. At first, functions seemed weird and kind of dumb, maybe, but we hopefully, I think, eventually got sort of warm, cozy feelings about functions, and we're like, oh yeah, like those are actually kind of useful. So same idea with this. All right, so here's the cleaned up version of the code we just wrote, and I do this to point out a couple of terms. So these two over here, base case and recursive case. So hopefully this goes without saying, maybe just by looking at this, but I think I have this on the next slide, so I'll say it first and then. So the base case, and there could be more than one, but at least in this example we just have one. The base case is the term that's used to describe the chunk of code or the case of the ifs and else ifs and all that. It's the portion of code for which the function is going to stop. In other words, there's no repeating in the base case, or in other words, these describe when to stop. Right, so let me put that next to it maybe. So the base case describes when to stop repeating. Which, of course, 99 times out of 100 is when you sort of reach the end, so to speak, right? So probably most of the time, your base case is going to be probably when temp is null, or maybe when temp's next is null, something like that. So for the most part, the condition that's going to be in your base case is probably the equivalent of the while loop condition. So most of the time, especially if you're thinking about translating over, for the most part, what's going to be your base case or base cases are going to be the things that describe when do you want to stop repeating. And then, so of course, that's essentially the condition that's in most of the while loops that we've written. Okay, so that's the base case or base cases if there's more than one. And then the recursive case or the recursive cases, these describe for the most part the action is here. The action of the function is here. As well as calling the function again. Right? So this, of course, this has repeats. Or in other words, the recursive case or recursive cases are going to say, okay, do something, right? Do whatever the action is that this function is supposed to do, but then call the function again. Right? And again, you will have wanted to make sure that whatever variables or whatever parameter you send, you want to make sure it gets an update. I mean, the mistake that we're all going to probably make is the same mistake that we all make sometimes when we forget to do temp equals temps next, right? So if I just cross that out for a minute, then this is going to say, oh, okay, print my number, and then print myself again. So it'll come back through and it'll print the same number. And then you'll say print myself again, and it'll print the same. Okay, right. So of course this is the equivalent of forgetting to do this with our loop, which we know makes for an infinite loop. Right? So one thing that we just want to remind ourselves that in the base case or base cases, recursive cases, is that not only are we going to call the function again, and it's usually sort of the last thing you do in the code that you've written. Not only do you want to call it again, but you also want to make sure that whatever you're sending it, that hopefully that's been updated in some way. All right? So those are the two terms, base case and recursive case, and I define them for you here as well. So what should all recursive functions have? So you need parameters, sometimes just one, but sometimes more than one. And these parameters need to, again, be somehow updated during the function, typically in the recursive case, mostly. So, right, so parameters are going to be the way that we actually sort of move through this. Let me go back to the one that we have worked out here. Right, so in this case, temp is our parameter. Temp starts at first, and then we toggle it each time. But what's remembering or holding on to that is the fact that every time the function is called, that's been updated to basically be the next box. So parameters are actually kind of the way that we keep track of the evolution through our process. So parameters, not that they haven't always been important, but they're actually almost even more important now because they are sort of controlling not only information. Obviously, when we think about parameters, we think, oh, well, this is information that I need to send the function so that it can do its job. Well, that's true, but in this case, at least some of the parameters are the information that they're storing or holding on to is essentially your progress through the list or whatever it is structure we're looking at. All right? So parameters are going to be our very best friends for sure. Okay, base case and recursive cases, I think I described those on the last slide, but you can read that again. Now, if you have a return, so if the function is not a void function, if at the end of the day this is supposed to be, sending some number back to the main or something like that, then how do we sort of pull that off? Well, the answer is going to be that we're going to obviously need return statements in the function. But since any other function that you've written that has a return, probably you just say, oh yeah, okay, I call the function does its business. And then at the bottom of the function, I say, and now return, whatever, right? Whatever the value is that you've worked on and are now sending back, right? Well, we're not going to really have that luxury with a recursive function because, of course, remember, a recursive function is going to call itself over and over and over and over again. So I don't just have a single run through this function for which I would say, oh, okay, when you get to the bottom of the function, send back your computation or whatever you did. I can't really say that. Instead, I'm going to have to sort of get a chain of returns going where I say every time I call the function, maybe I'm going to end up calling the function 10 times. I need to sort of establish a chain of returns, so to speak, which is to say that every time I call the function, I probably want to put a return statement in front of each function call. And in essence, what that's going to do is imagine you have 10 people lined up, next to each other, and you're going to tell the person on the one end the password or whatever, and the goal is to get that password passed all the way to the first person in line, right? So in other words, from one end of the line to the other. Well, that doesn't work unless everybody's been instructed to pass along the message to the person next to them. So when I call these functions, unless I'm saying, oh, and send your message back, and send your message back, and send your message back, I have to sort of make them all send the messages back to each other. You'll see this. I'll do this in an example. But remember this one. This is the one where often you sort of, everything you wrote looks great, and at the end you're just like, why does it keep saying that the answer is 0 every time? And the answer is because you're not doing enough returns. So, well, anyway, we'll look at an example of that. So those are things that you should do, 1 through 4 there. A thing you should not do, which again does take a little bit of time to break this habit, is that you basically, I would say almost never, in fact I would say pretty much always, when you do a recursive function, you're not going to be using or declaring any local variables. By local variables, I mean variables that you make at the beginning of the function. The reason just being that, of course, think about a function that's going to call itself 10 times. Every time you call that function, it's going to make a fresh copy of that variable. Now, not only is that wasteful of memory, it's also the case that every time you call that function and you make a new version of it, it's been reset. So I'm not really sure what purpose you would even have for doing it. I suppose if you have like a dummy variable because you're doing some sort of swapping, maybe. I guess I could see there being maybe a small opportunity for which you might want one. But for the most part, maybe I'll say for the most part, you're probably not going to be declaring any local variables. So if there is something that you want to keep track of, and again, this is a little bit of an art here. So if there is something like a running total, like we're going to do a function in a minute where you're going to sum up the numbers, well, we know that I would make a variable called sum, and I would just run through the list, and I would keep adding to the sum, and I would return it at the end. But sum would be a local variable that I just create when I start the function. Well, I can't do that now, because again, every time I call the function, that sum would get reset to a random number. So if there are things you want to track like that, then those things need to be either parameters or has to be the quantity that you're returning. Okay, so we'll come back to this too, because this is a little bit of an art, and probably in words that doesn't make a whole lot of sense, but come back to that idea. So let's try one. So let's do what I just alluded to. So let's say that we have a linked list. I'm just going to make one up here at the top. Do I want to put it here? Maybe I'll put it over here. So I have a linked list, and I've got some numbers in it. I'm just going to make some things up. 10 and 4. And 6. And that's the end. Okay. So there's my linked list. Just a regular linked list. And I want to sum up the numbers in the list. So obviously we can already see the answer should be 20. So when I call this function from the main, My goal would be to hopefully have this send 20 back to me. Aha. Okay, so in terms of how do we do this? Right. So getting started with this, of course I would maybe think, well, how would I do this without recursion? If I was just doing a loop, I would probably make a temp, and I would probably point temp at first, and I would probably make a variable called sum, and I would probably just keep updating this by adding in these numbers, and then I would go to the next box and add that in, and go to the next box and add that in, and go to the next box, and once I reach the end, I would say stop, and I would return the value stored in sum, right? I think that's probably a reasonable verbal pseudocode of how you would code this traditionally. Okay, well, as I just got finished saying a minute ago, I don't really have a variable. I don't want to make a variable here called total or something like that. I called the function sum, so I probably shouldn't call the variable sum, but I don't think I want to make a variable for that, because every time I call this function, that's going to be reset. So when I'm thinking about designing this thing, I might say, well, one thing I want to keep track of is my running total. Now, anything you want to keep track of probably is going to need to be a parameter in your function. So let me make a variable or a parameter called total, which is an integer. So that's one thing that I think when I'm running through and repeating that I want to update. So let me do that. And then what else do I need to keep track of as I go through this list is, of course, where am I right now? So just like in the example we had a minute ago, I probably want a pointer in order to help me scroll through the list. Again, these are just the things that I had up here a second ago, right? A variable to hold your total, and a temp to scroll through. Well, rather than those being things that I create inside the function, I'm going to make them parameters to the function. Okay? Now, there's no rhyme or reason for how you fill this thing in. Maybe if you want to, you could think about, so when I call this from the main, what should I send it? Well, if I'm going to try to send it, what's the total so far? Or, the parameters are, what's the total so far? And where am I in the list? Well, hopefully that's clear, that when I'm in the main, what's my total so far? Nothing. And where am I in the list? Well, I'm pretty sure I want to probably start at the beginning. So if I send this 0, just the number 0, comma first, that'll store a 0 in total, and that'll store first in temp. In other words, this will make temp point to first. All right, and I'll keep track of total maybe under it. And total right now is 0. All right, so this is the new way that we're going to do that with parameters. Okay, so now let's say I'm in the loop. So I'm in the function. So I'm in the function, and temp is pointing somewhere in the list. And so I want to think about, what do I want to do when temp is pointing somewhere in the list? Well, once again, I have two cases, I think, to think about. One, I could think about the base case, which is just going to describe when do I stop. And then I also want to think about the recursive case, which is when do I want to keep going? It's often easy to fill in the base case first, just because it's usually easy to identify what you want to do when you stop. So I think hopefully it's kind of obvious that I would probably want to stop when I get to the end. So if temp happens to be over here on the end, I think for sure that's a situation where I know I'm done. I know I don't want to repeat anymore. Now the question is, what do I want to do? I mean, I could print a message. I could say certainly I could say, you're finished. Or you've reached the end or something like that. So let's leave that for now, right? So let's say, let's leave that. All right. So for sure, that spiritually at least, that's certainly true. That's where I'd want to say you're done, and I certainly don't need to call the function again. All right, let's go to the other case, though. So the other case is where I'm actually pointing to a box. So if I'm pointing to a box like I am in my picture up here, then what do I want to do? Well, for sure, I want to update total. And in fact, I probably want to say total equals total plus my number, right? That would, of course, say your previous total, or sorry, your new total is your previous total, plus the number that's in the box you're currently looking at. So, of course, for us, if I did this on the first round, temp is pointing to the 10 box, so total would get updated to be 10. And now if I want to say, what else do I want to do? The recursive case is where I'm going to say and repeat. But of course, I don't want to repeat this just as is, because temp is still pointing to 10. So I think another thing I want to probably do is move temp over. Okay. And now is where I maybe want to say, and now repeat this whole process. Okay? So I could say sum. That's the name of the function. So call the function again. And send it, let's see. So now thinking about the function, right? So the function has two parameters, total and temp. So now total got updated, right? So if I send it again, or if I send it down here, it has been updated. So in our example, it would be 10 right now. So that's good, because I want to remember that you've updated it, right? Okay. So so totally okay. Temp also got updated. So when I send it here, it's going to say, all right. So I'm now pointing at the next box. So when I come back to the top of the function and I run it a second time, total is now 10, and temp is pointing to the 4 box. That's pretty good. So now when I run it a second time, this is still not true. I'm not at the end. So I'll do the else case, which of course just does an update of total. So total now gets updated to be 14. Temp gets toggled to the next box. And now I call the function again, and I send it 14 and that third box. Okay, so I come back to the top one more time. The base case is still not true, so I will do an update to 20. And temp gets updated to go to the next one. And so when I call the function again, now total is 20, and temp is pointing to null. So I call the function, in this case, for what's going to be the last time. I call the function. Now for the first time, this case is finally true. Temp is null. Okay? So now maybe is a good point, a good moment to say, all right. So what do I want to do when I reach the end? I can leave my little cute message of you're done. But of course now is when I want to say, well, this is the last time I'm going to do this function. And remember, the main was very patiently waiting. It was hoping that you would send back the sum. So hopefully it makes sense to say that here is where I probably want to say, and send back total, which right now is 20. Okay, so hopefully it makes sense to say that when you send this back, right, you're in order to do a return back to the main, which is of course where this was originally called, I need to decide, well, when do I want to say that I know my answer and sending it back? Again, in a usual function, this would have just been the very last thing you wrote. It would have been probably the last line in your function would have said, and now send this back, because it's prepared, it's finished, right, it's ready. All right. So the same idea works here. It's just that rather than it being at the very bottom of your program, it's part of your base case, right? In fact, it's the last thing you do in your base case. Okay, so now's the part where if we were in class, I would ask someone with a keen eye to tell me, is this going to work? So I'd say this is 98% right. So I think our little analysis over here was pretty good. 20 is certainly stored in total when I reach the base case, or when the base case is true. I certainly am going to send 20 back, right? So when I finally get to there, 20 is the number that's stored in total, so that's good. Now the only problem though, and this is what requires a little bit of a keen eye here, is that where does this get sent back to? Now I think in our lives so far, every time you've had a return statement that you've typed into any sort of function, the answer has been the main is who gets the return. So when you return a value, it goes back to the main, and the main does whatever it does with it, which would be great if that's what happened here, because the main is the one who wants to know what's the sum. But unfortunately, the main is not who called the, the fourth round? Fourth round of this process. The fourth round of this process was called during the third round of the else case. So I'm going to make this clearer, but let me finish the story here in this video anyway, and we'll come back and pick up with this next time. But, right, so where does this 20, so for sure the return happens with the number 20 there. But where does that get sent back? It actually gets sent down here, not to the main, because the else case is what called the function its last round, right? When temp was over here on null, it was because it was called down here. So that number 20 is actually going to be returned here. Uh-oh. And so where does it go after that? Into the darkness, unfortunately. So the only way to make it establish a chain of sort of returns to get all the way back to the main, and this is what I was alluding to earlier, is that anytime you call the function, you probably want to throw a return. So sorry, the format of this is a little ugly. But when I call a function, when I do a recursive call, if at the very end of the day you have a return that you want to send back to the main, unless you establish that in both cases you're returning whatever the previous round did, you will not effectively be able to sort of send the message all the way down the line. It gets stuck at the end. So if I do this, right, so this works. So what we now have on the screen here is perfect. So it's going to do this thing, it's going to run through the list, it's going to eventually total you up to 20. And then when this gets sent back, and it's 20, it's going to get sent down here. Oh, so this will become 20. But then that's going to get sent back to the previous round. And then that's going to get sent back to the previous round, to the previous round, all the way until the first round, which is back in the main. All right? So sorry, let me just clean this up a little bit before I leave you here. Okay, so that's going to require a little bit of unpacking, I think, to establish that that's actually what really happens. So I think, just preview, yes, okay. So the next slide, which we'll pick up with in the next video, is going to be a good way for you to visualize what actually is happening when you call these recursive functions, and it's also going to help you as the designer of these. Because, of course, most of the time you're not given code that you then try to interpret, although I guess I like to do that to you on exams. But most of the time you're sitting there and you're like, hey, I want to write code that does stuff. So I think having a better understanding of what I just described in the last 2 minutes and having a good way of visualizing that is going to be really helpful in helping you get better with coding. So stay tuned for the video on that, which will be forthcoming. There will be a lab for this, of course, which at this point I don't have posted just yet, or I don't know when you're listening to this, so I'll say it's Tuesday, the 31st, so I don't have it posted just yet, but I will post it shortly, that you can then try your hand at writing some of these recursive functions, which, as I said at the beginning of the video, is going to be something that we're going to be using all the time. So we do want to sort of get good with it on easy examples like these.